Hello, my name's Peter Fisher. I'm a freelance web and mobile applications developer. I'm also the host of the How to Code Well YouTube channel, which is where I talk and teach code. And today I want to talk about why it's so complicated. Why is web development so complicated? Because for the past, 12, 13 years, there's been this question that either I've asked or someone on the team has asked, and that is, why are we doing this? Why is it that we're going from A to B, but in order to do that, we have to do X, Y, and Z? Why is this so complicated? And if you think about it, different industries have created or developed things in a very easy way. So manufacturing, the process behind making something is actually extremely simplified, and it has done, and it's been simplified over time. The thing is, I'm not talking here about the end product. I'm not talking about the thing that we give our clients, because actually they need to be simple. That needs to be simple. The actual way to get from the user, from getting to the page to getting to checkout, that has to be extremely simple. And so there's lots of work about how to remove the processes involved with that user journey. I'm talking here about the actual development process, the actual thinking space, the actual thinking about the architecture, all the impacts and implications that different things have that actually just make the whole thing extremely complicated. And I'm going to do this in a couple of ways. So the first of all, I'm going to ask who and what is to blame, because it's always nice to blame someone, right? Then I'm going to try and answer why-ish, and then I'm going to give some keys to simplicity, although I should say I obviously don't know all the ways to simplify code, and to be honest, there's not really many, but I'll try and give you some stories that I've found in my career. Okay, so the first one, who and what is to blame? So is it us, the developer? Are we to blame? Are we making this complicated? Are we overcomplicating the solution? Is it because we're programmers that we are gravitated towards complicated things, and so we make things more complicated? After all, we're problem solvers, right? We like to solve problems. Is it because when we write code, we're writing code in a way that is very one-to-one, in the sense that it's me writing code, I'm going to go to the page, refresh the page, and yeah, it works. But in actual fact, when you deployed this code to a production box, there could be thousands, hundreds of thousands of REST requests coming in. That box is trying to do all sorts of different things at once. So you can't actually get into that sort of headspace. So perhaps our testing is wrong. Perhaps the way we test by just running a unit test is wrong, because we haven't anticipated how many requests take a server down. Maybe it's the technology. Maybe the technology is the thing that gets in the way. Maybe we're not using the right technology. Maybe the right technology hasn't even been invented yet. Maybe things like, not just the technology, maybe the methodology. So perhaps Jira is a thing that overcomplicates things. Perhaps the whole Scrum thing is just a barrier of entry. Maybe it is the client. Now, I'm a freelance developer, and I've had lots of clients over my time that have completely overcomplicated the game. Lots of requirements changing left, right, and center. And as a developer, that's very difficult, because you've made this beautiful piece of code, and now they've come and they want to change such and such, and you have to then refactor what you've done, and you're refactoring that in less time than it took you to actually, or forcing to less time than it actually took you to write that beautiful code. So maybe it's the client. Maybe the client just doesn't know what it wants. And I've had that a couple of times. Is it the end user? Is it the user who's actually using the application? Maybe they're using the application in ways that the application wasn't meant to be used in. And therefore, as a developer, we have to adapt to that circumstance. Okay, so that's who, what is to blame. And to be honest, they're all to blame. So blame all of the things. So why is software development complicated? I've discussed the blame game, but really what is the thing that makes software development complex? Well, This might be a bit of a brutal statement, but software, in my opinion, is both invisible and it cannot be visualized. So I'm in this rather stressful process of buying a house. And the house, I've seen it, I've been in it, I've walked through it, I've measured it. If I wanted to, I could create a scale model of the house in cardboard. I could create furniture and move the furniture around. I can see it. You could even say that you can touch it and smell it and all sorts to it. It is something that I can visually see. However, with software, you can't just pick two pieces of software, put them to the light and go, oh yeah, look at that. That's wrong. So it is invisible in my opinion. And also, this is true not only with new projects, so projects that complete blank slates, you haven't written a line of code. It's also true with legacy as well. Because if you think of cars, there's two ways, well, in my opinion, in my experience, there's two ways that you can tell if a car has a problem. It either makes a loud noise and you turn the radio up, or it starts to smell and it makes pours out smoke. Very visual, very sensual, very sensory things. But with software, just imagine if every time you went on your mobile phone, the phone started smoking because there was a bug. You can't see it. You cannot see it. Words such as root cause, investigation, and discovery are all entwined with bug fixing. Whereas, yes, the car is broken because the wheel's fallen off. Or, yes, I want to extend this house and I can actually see the measurements. I have a blueprint. I know exactly what I need to do to this house. I know exactly where my house starts and where another house begins. It's very difficult with software, especially with dependencies. Software is constantly changing. So, with talking about cars again, so with a car, every time you change your car, you buy a new car. You don't go to the manufacturer and go, I've got this car, please change it, please upgrade it. Unless you're obviously a niche and you're a hobbyist and that's what you do. You like to actually modularize cars. But cars, from a manufacturer's point of view, aren't modular. In fact, the only reason why manufacturers change cars is because Volkswagen has done something really bad with the engine and has to recall everything again. But imagine if you are writing software and every time you add a new feature, you delete everything you previously did, and then you build everything again, and then you add the feature. So software constantly changes, and we have to adapt to these things. Why is complexity so bad? Because, listen, we could just go, you know what, software development is just complicated. Let's just get over it. Let's just accept it, and let's just get on with our lives. But it's bad, and it's bad because it costs. And there is a slide later on, which I should have put on here, which is all about how complexity isn't always inevitable. So complexity leads to communication issues. So this means that when, for example, a techie is talking to a non-techie, right? You're trying to decipher what this non-techie guy, girl, what have you, is trying to talk about. Assumptions get made. It's also vice versa. If you are trying to talk to a technical person and you're assuming what they are saying and they're assuming what you are saying, then you end up with product flaws. Product flaws create delays. Delays create cost because you're always having to rehash all the stuff that you misinterpreted. And the amount of times I've heard clients say to me, oh, I assumed you would do that. No, I'm not going to do that. Why would I do that if you haven't written it down? I'll ask you if you want me to do that. So, complexity leads to communication issues. Complexity also leads to difficulty in enumerating, less understanding of the possible states of the system. So if you imagine the most complicated software that you've ever developed, now try and think of every possible conceivable state that piece of software has in your head right now. It's probably going to make your head explode. Complexity leads to ugly code. Because the more complex the code becomes, the more issues you have with trying to integrate things, the more stuff you pile on like a big Jenga pile, it just gets very, very ugly. And it gets very hard to integrate with other pieces of code, with other dependencies. That over time creates a maintenance overhead, and it's very, very difficult to extend. So all of these, you can't really equate money to them, I don't think, but you can actually, they are costing businesses. Complexity leads to the unknown. So your piece of software is being used by the end user in ways in which you do not anticipate. And therefore, you're going to get security breaches, you'll end up having to do rewrites, and over-abstraction. So with over-abstraction, it's kind of like when you try and abstract something to the nth degree, you think, oh, because I don't actually know what this should be doing, I'm going to abstract it so far. And, you know, it's all good because we're not reusing code. We're not reusing code, the whole don't repeat yourself thing. But when it comes to actually maintaining that, you have to go through several layers of abstraction to actually get down to the little thing that you want to change. So over-abstraction is, in my opinion, not a fantastic thing. This is my favorite one. Complexity leads to fickle business decisions. So how many of you have been into a meeting with a potential client or whatever, and they're talking about this new fantastic feature, and they say, why don't you just add a flag to the database? Simple, right? You just add a field to the database. There's no harm done. Just, you know, you don't have to tell anyone. Just put the flag on the database. How many flags on the database will there be before you lose data integrity? How many times does your system need to bloat even further? Yes, you're doing one little change, but over time, that's actually quite a lot. And through experience, I know that this is a high barrier of entry, because usually what happens with junior devs is when they go into a new place of work, they get put on maintenance. They get put on the backlog stuff, just so they can understand how the code works. Well, if you can't understand how the code works, how on earth are they going to understand how the code works? And I've been into projects before where it is like an elephant graveyard, and you are looking at features that haven't been used. I've written a lot of features that haven't been used because the client goes, oh, yeah, you remember that month where you were working on this thing? We're not actually going to use it. So that's a high barrier of entry, and that will increase personal turnover. So this is kind of like one of those costs that will creep up and bite you in the ass later on. So complexity leads to fickle business decisions. Here we go. Complexity is the most common difficulty in software development, but not all complexity is inevitable, because if you think about all the complexity points, if you will, and I say points, I don't mean like story points on Jira or anything crazy. If you think of all the points and see if you can simplify them, you're actually making the job more efficient, which means that you are saving money in the sort of the long run. Now, this is a fantastic book, and I've got a copy myself. Mr. Frederick P. Brooks has a whole series of essays in the Mythical Man Month, and I'm going to pull some particular parts from the No Silver Bullet essay that he wrote. It's fantastic. It's really thought-provoking, so I do highly recommend that. And he says essential complexity and accidental complexities are two layers of complexities. So you can sort of boil down software development complexities into these two things. So I'm going to be talking about these in the talk. Now, essential complexity. Essential complexity is complexity that is a feature of a system. The more features you have in the system, the more complicated the system is. It makes brilliant sense. But The key is essential. Essential features, essential complexity. So it's if it's a feature, in this sense, it needs to be essential. I'm just going to swig some water. Nice to haves are only nice if they enhance the core functionality. Bear with me a moment. Right, so here I'm talking about the difference between legacy and new stuff, and a new project coming in. Because, so a couple of startups that I worked for, they were fleshing out some ideas. They were thinking about some things, but they never really decided, or some of them at least, never really focused on a mission right at the start. It took a while before that came out. And so they ended up creating all these wonderful ideas, these great features. Why don't we do Ajax and make it nice and lovely and animate it and transitions and all this stuff? That was all nice to haves, but nice to haves are only nice on the first release if they enhance the core functionality. Otherwise, you are extending and delaying and having humongous overhead with the whole development process, because you're putting in bloat before you've even released it. And you don't actually know any metrics that suggest that those nice to haves are nice from the user's point of view. So they're only nice in your head. And there's been lots of times where people have perhaps had nice, what I call shower thoughts. Oh, I woke up this morning, had a shower, and I thought about this project, this feature, and I'll see if I can slip it in this first release. But if they're not enhancing the core functionality, then really there isn't any point. What I say is write down your essential features, include a justification for each essential feature. And again, I reiterate, this is when you're coming up with a new project from scratch, right? Will 80% of the system function without the essential feature? If so, it isn't essential, in my opinion. Every time a feature is added, the level of complexity is increased across the entire development lifecycle of the project. This means that testing from a code level, UAT, this could even be focus groups checking out your code, or it could just be the client just approving your stuff. It could even be automated, of course. Load testing, integration testing, integrating that feature with other features. Documenting, you have to document your stuff. Training, not only for you and another developer to actually show them what exactly you've written, but also training to the client and to the end user. Designing, and I don't mean just designing nice graphics with whatever, it's designing, architecting the actual solution. And of course, development time and maintenance. All of these things get extended every time a new feature is added. So I say, have a meeting every time an essential feature is added, because everybody should be involved in this. The developers need to be involved in this. You need to think about how this is going to affect and impact the other systems. And also celebrate every time an essential feature is removed, because you are making the thing less complicated and therefore more simple for the end user. Okay, so in this example, menu A has 100 options, whereas menu B only has 15. Which one is more complicated to the customer, the waiter, and the chef? Well, it's going to be menu A, isn't it? One with 100 features. Because let's say, for example, you have one day, 25 of those menu items just aren't available. Maybe there was a problem with delivery. The waitress and waiters have to remember all of those 25 items. So when they go over to the customer and say, oh yeah, by the way, this isn't ready, this isn't here, and this is off the menu, blah, blah, blah. You have to store all the ingredients that make up these 100 menu items. So your storage capacity is huge. Your stock taking is also huge. So in terms of software, that's like checking the logs, log reporting, and all that jazz. And the chef has to be specialized in all of those things. So there's a full stack dev. So how many essential features do you think Twitter has? And if perhaps, let's say something happened with to Twitter and heaven forbid, and maybe the photo feature went and the video feature went. So you could tweet. You could still tweet, but you just can't upload photos of your food. Yes, there'll be uproar because nobody can send photos of the food, but there'll be more uproar if you can't just simply send a 145 or whatever character it is tweet. That is the essential feature, and all the other features around it. And I go back, this is the first iteration of Twitter. They are non-essential right now. And obviously, over time, they've grown those features and so forth, but they enhance the core functionality. So here again, if you're starting a project from scratch, then only the essential features should be included in the first release, because then you can quickly get measurements back from the users who are actually using it, because the amount of times I've created non-essential features and gone, right, we need to actually check and ensure that people are actually using this thing, and then find out that it's not as great as we thought it was. So we've dropped it. Okay, so that was essential features. Now this is accidental complexity. The beauty with accidental complexity is it's our fault, which means that we get to fix it. We should be fixing it. It's all about you making the accident. So this is away from the features. You've now got the features. You've agreed on the features. You're actually developing these things. And again, I'm splitting this up between new projects and legacy projects. In the new project, everything is box fresh and shiny. So you're a magpie. What framework should I use? Is it going to be SQL or no SQL? Oh, gosh. Whereas if you get given a legacy project, you are basically landed with a steaming pile of source code on your lap. And you have to fathom out what on earth this developer did several years ago on this thing. Yeah. Now, new project. You make all of the mistakes. There's a high risk of overgeneralizing the requirements. So, this is story time. Overgeneralizing. I have done numerous interviews and numerous tests. Two that come to mind is I was asked to build Monopoly in JavaScript. The other one was a fighting game in PHP where two teams of things were fighting each other. And they all had like health and stuff, strength, and they fought, and you had to randomly work out which one was the winner. The tests themselves don't mean anything in this story. It's all about how I was given the requirements, because I think that the requirements were written in a very tricksy way to trick me. And I was fortunate enough on one of those positions to actually get the position and be there long enough to assess other developers who did the same test as me. And I always remember there was one time where it was a bit like Britain's Got Talent, where you got around a sort of a table and you were looking at CVs and you were looking at code and you were deciding which developer you would bring in for the next interview. Team leader piped up and said, I want to bring this guy in. And we were like, but, you know, the code here is fantastic. Of course, we were all the shiny, you know, look at what he's doing, look at what he's doing. This is great, he's used that framework. I said, no, I want to bring this guy in because he's asked questions. The communication between us has been fantastic. He knows exactly what he needs to ask, and it's been brilliant. Because the thing is, the requirements were, I was told exactly how the system should function in the sense of sort of the PHP way, the actual back-end way, but I was never told in that requirements document how it should be presented. And so people were making some really crazy general assumptions. We even had animation. We had guys doing crazy animation. We had people doing crazy transitions. We even had people doing backstories for these things. It was nuts. And this team leader knew this and was like, yeah, I want someone who asks me questions, not someone who's just going to assume what I'm doing. So that's what I'm talking about by overgeneralizing. So basically keep it simple, stupid, which is KISS. Okay, so the legacy project. Okay, so if you can decouple, downsize, and defuse the complexity from a wider system, then that is a win. And I can say it's a win because there are projects that I've done where the code was so intertwined that the way we got around that was to remove that crazy feature into another space, another environment, and create some APIs around that. And by doing so, we decoupled it, we defused the thing because we didn't really fully understand how it integrated with the rest of the system. And so by defusing it, what you're doing is you're making it less dangerous. You're making the fear of injecting the rest of the system with stuff. And we essentially started by piecemealing all of the problem areas, and then we have a very, I guess you could call it microservices, I suppose. And this thing here, if it isn't broke, don't fix it, does not fly with me with software development. Because if the code has been written and it works, doesn't mean that the code shouldn't be rewritten. Because technology changes so fast and versions of things change all the time. Things start making, get more efficient. Take PHP7, for instance. So just because something works on a PHP 5 box doesn't mean that you shouldn't just go in there and change it and upgrade it to PHP7. And by doing so, you make it more efficient, more cost effective. But the thing is, it takes a very bold developer to go, yeah, you know what, this code that works and has worked for several years, I'm actually going to rip it apart and change it. I kind of see this like, so you've got a table and you've got all your legs on the table. Not your legs, the table legs. You've got the table legs. And you're unscrewing the table leg. And you're fitting another table leg on, which is lighter and more efficient, more cost effective. However, you've got all of your food and cutlery on the table, and you can't let that table collapse and fall over. So it does take an interesting mindset to actually look at stuff that is already working and see if you can make it work better. And the thing is, this is a very challenging thing to convince people to do, because their argument is, well, it works. So why would I change it? And, you know, I want to be working on this new feature, this new shiny toy. So this is my little simple equation. A plus T equals S. Accidents over time, or accidents plus time, equals a steaming pile of source code. The more accidents you have that you leave over time, the more it's going to create steaming piles of code. Okay, so I'm going to try and talk about some ways to simplify things. So this is a quote from Mr. Brooks, Mr. Frederick Brooks. Software entities are more complex for their size than perhaps any other human construct because no two parts are alike. Excuse me. So the human body, let's talk about that. We've got 2 arms, we've got 2 legs, we've got 2 knees, we've got 2 eyes, and we've probably got 2 other bits and pieces. With software, with code, you rarely have 2 of the same thing. In fact, you shouldn't have 2 of the same thing, because you're taught to write things in a way that where you don't repeat yourself, right? And therefore, by having lots of little things that do different things, it is inherently complicated, because you're having to manage all of these little things. So don't repeat yourself, don't over abstract, and don't over generalize. That's kind of my three rule. And also an interesting one is code that glues 2 systems together is often easier to write and maintain compared to a monolith from scratch. So let's say, for example, you were given some code or given a requirement to do 2 very different, distinct features all in one system. Well, you could go about it and just build the whole system from scratch in a bespoke kind of manner, right? Or you could go and actually have a look and see if there is features available off the shelf that you can bring in, and then make some glue code, some API stuff and all that jazz. You then only have to maintain that glue code. You don't have to maintain the whole monolith that you're creating. Now, I do appreciate that you aren't in control of these two features that you've just bought off the shelf. That's up to their developers to maintain and fix and secure. So I do appreciate that there is complexities that you aren't in control of. But the thing is, and I think this is on the next slide, yeah, build versus buy. So the thing is, when you are with hardware used to be extremely expensive years ago, like crazy expensive. We're talking hundreds of thousands, if not millions of pounds. And the software was in proportion to that. So if you bought something for £1 million, then £250,000 for software didn't actually feel that bad. But you're not going to buy software now for that amount of money because the hardware has reduced in cost so much. So it's more cost effective to buy things off the shelf sometimes than it is to actually code the damn thing from scratch. And so this is kind of my opinion that software should be grown and not built. And I go back to the car analogy where the car just comes off of a conveyor belt. You just build a car, and you build a car, and you basically set and forget it. Whereas with code, it's more, in my opinion, organic, it's fluid, it grows, it adapts to the ecosystem and the environment that you put it in. And you don't ever just delete code like from scratch and then start that again with new features. You grow with it, you adapt with it. And the skill sets that you bring in to the team also help that to develop and grow as well and blossom. So another quote here, we still make syntax errors to be sure, but they are all fuzz compared to the conceptual errors in most systems. If this is true, building software will always be hard, and there is inherently no silver bullet. And again, that's from the Mythical Man Month essay by Frederick P. Brooks. And to just finally say, getting simplicity right is complicated. Thank you ever so much. Please give me feedback.